Good afternoon, I'm Professor Sever, and today we're going to investigate graphing linear inequalities in two variables. Our goal is to determine the feasible region defined by this system of linear inequalities. As you can see, we have 5 linear inequalities defining the system, and yes, we should verify that each of the inequalities is in fact linear, and they are. This comprises a system of linear inequalities, and what we want to do is determine the feasible region, also determine whether that feasible region is bounded or unbounded, and finally we want to determine and label all corner points of the feasible region, which is really the solution set to this system of linear inequalities. So what's our overall plan? So first we need to sketch the linear equations which underlie the system of linear inequalities. Then we want to use a test point or test points to determine the feasible region. We'll shade the feasible region as our final answer. It's a graphical technique as stated in the title to this video. Again, we will determine whether the feasible region is bounded or unbounded. And finally, we want to identify the corner points of the feasible region. So first, let's sketch the lines. Now, one thing you would want to do when you begin, really we should label for easy reference. This is line 1. This is the first linear inequality. This is the second linear equality. This is the third, fourth, and fifth. Now, these last two are called the non-negative constraints, and we'll discuss those separately in a moment. When we go to sketch the linear equations, I'm going to consider this to be the inequality which defines equation 1, this to be the inequality which defines equation 2, and this to be the third inequality which defines our third linear equation. And we will first graph those in turn. As this is an introductory video, we will graph these separately and then look at actually how you would do it from the perspective of a student. So portions of this video are intended to be instructive. So let's sketch the lines. So first, as you see, I've taken the first linear inequality, and the first thing you want to do is replace the inequality with equality. This gives us a linear equation, which we know how to graph. We need 2 points. For convenience, I'm going to choose the x and y intercepts to graph the points, and I will solve for the intercepts accordingly. To find the x-intercept, we know the y-coordinate has to be 0, so we replace y with 0 and solve. I have the work here. Remember, we're substituting the 0 for y. 2x plus 0 is 22, which yields 2x is equal to 22. We divide both sides by 2, or you could say we multiply both sides by a half, yielding x is 11. Now remember, the intercept is an ordered pair, so really we've already said that the y value has to be 0. So the x-intercept is 11, 0, 11, 0, the ordered pair. Similarly, we need to find the y-intercept. To do so, we replace x with 0 and solve for y. Doing so yields 2 times 0 is 0, 0 plus y is y. This just gives us y equal 22. So of course the intercept is the ordered pair 0, 22. So we have 11, 0, which is here on the x-axis. We have 22, 0, which is here, and I will now sketch the line. Included in the solution because it was solid, and I should have referred to that. So let's go back. Let's recall the original inequality, which was less than or equal to. So before I use these 2 points to connect the dots and draw the line, I need to determine whether the line should be solid or dotted. Since the inequality associated with this equation was less than or equal to, namely the equal to was there, as you can see over here, then we know that the line has to be a solid line. In fact, we see in each of the cases we will use solid lines rather than dotted lines. If the inequality had been just less than, strictly less than, or strictly greater than, we would have used a dotted or dashed line. When I graph, I will use solid lines for all the lines comprising our system. So this is the linear equation which underlies the first inequality. Let's move on to the second equation. So again, you want to replace the inequality with equality, and then this determines our second linear equation. We will solve the intercepts in the same way. We will, to find the x-intercept, we replace y with 0 and solve for x. Doing so gives us 2x is equal to 50. Multiplying both sides by a half gives us 25. So of course, again, the ordered pair is 25, 0, which is here on the x-axis. To find the y-intercept, we replace x with 0. Remember, if you're an ordered pair on the y-axis, what's your x-coordinate? It's 0. Therefore, to find the y-intercept, we know the x-coordinate must be 0. We replace x with 0 in the equation and solve, which yields 5y is 50. Multiplying both sides by 1/5 yields y is 10, so the y-intercept is 0, 10. And there is our second linear equation drawn in green. Okay, moving on to the third equation, which comes from our system of linear inequalities, and that gives us, again, solving for the intercepts, we get x equal 13 when you replace y by 0. That gives us the intercept 13, 0, which is on the axis somewhere here. And the y-intercept, you replace x with 0, yielding y is equal to 13, which gives us a 13 on the y-axis, or remember, the intercept is 0, 13. And there is our third linear equation, which comes from our linear system. Okay, now remember, we also have the two non-negative constraints. So remember, x equals 0 is just the y-axis, which is here. And that's our fourth line, and then our fifth line is y equals 0, which we know is a horizontal line. Remember, x equals 0 is a vertical line. Any equation of the form x equals k is a vertical line. So again, x equals 0 is the vertical line, which is the y-axis. Y equals 0 is a horizontal line, which is the x-axis. So these are our fourth and fifth linear equations comprising our system of linear equalities. And now you can see the four lines defining our system. The first one, the second one we graphed. And again, really, I would prefer you would label these. Normally, if I were in pencil and paper, I would write the equation of the line right above it, so I would always refer to it. But we see it here in the video labeled for us. And this is the third one. The fourth and fifth are the y-intercept, y-axis. The fourth and fifth are the y-axis and x-axis respectively. And remember, the order in which you graph these is immaterial. You have to graph them all. So now we need to move to determine the feasible region. But first, notice what we have here. We have all the equations graphed on the same coordinate system. And this is what you would do as a student. As a student, you wouldn't do the way it was presented here. You wouldn't graph the first equation separately, the second equation separately, the third equation separately. I did that for illustration. I wanted to separate the process of graphing each of the lines separately so you could see them in isolation. Normally, you would want to graph them on the same coordinate system at the same time. So you would graph the first one as we did, and on the same axis system you would graph the second one, and then you would graph the third one. And if we did that, the work would look something like this. So you would do the intercepts for the first line, intercepts for the second line, and you would sketch it. You would do the intercepts for the second line, and you would sketch it on the same coordinate system, and you would do the intercepts for the third line and sketch it. Now remember, the fourth and fifth are the easy ones. These are the coordinate axes, the x and y axis. And then you would obtain the following. Okay, so that's how it would be worked. I was being instructive in the original presentation. This concludes part 1 of an introduction to graphing linear inequalities in two variables. In part 2 of this video series, we continue this exercise and begin the process of determining the feasible region. I'm Professor Sever, and thank you for watching this video.